Warning! Under U.S. law, it is illegal to make any device to suppress or reduce the noise level of a firearm, or to attach anything to the barrel of a weapon with the intent of reducing the sound of discharge. This is a major felony, punishable by many years in prison. The Bureau of Alcohol, Tobacco, and Firearms, the ATF, actively investigates and prosecutes those suspected of federal firearms violations. In order to avoid violation of U.S. law, portions of this video were filmed outside of U.S. territorial jurisdiction. The information in this video is presented for its informational, academic, and entertainment value. Do not attempt to make any of the devices shown in this video, or you will be in violation of federal law. In this video, we examine the principles on which firearm suppressors or silencers operate. The suppressors shown here were made with the use of machine tools, lathes and mills, by this federally licensed manufacturer. But in this video, we will examine the fabrication of units like this one for the .22 caliber pistol. This device was made without the use of machine shop tools, using commonly available materials and simple hand tools. We then field tested these units using precision decibel meters and frequency spectrum analyzers. The results of these experiments were recorded and will be presented graphically. We will begin with a brief history of firearm suppressors. Born in 1869, Hiram Maxim is often credited as the father of modern firearm suppressors. The Maxim units used a series of baffles to cool and dissipate muzzle blast, thus reducing the sound of a gunshot. Here we see a bullet racing ahead of its own muzzle blast. It is these hot, high-velocity gases of muzzle blast that are the chief source of firearm noise. It should be noted that while now illegal devices in the United States, silencers were once popular items with turn-of-the-century sportsmen, as this 1922 Field and Stream ad testifies. This picnicker is shown with a Maxim silencer on his .22 caliber Quackenbush rifle. In fact, a former president of the United States, Teddy Roosevelt, was known to purchase and use Maxim silencers. The Maxim units attach to the customer's weapon by use of a special muzzle clamping device. Such muzzle clamping devices are available today through mail-order sources. Other devices which attach to the muzzle of a weapon, such as recoil compensators and flash suppressors, can serve as the base of an improvised method of suppressor attachment. The attachment method of the suppressor to the weapon's muzzle is critical. Any misalignment could mean the bullet might strike the internal baffles, blasting the device apart, which could injure or blind the shooter. In this next experiment, we deliberately misalign this dummy unit to show the result. The attachment method is critical because a misaligned suppressor constitutes an obstruction to the barrel. This could blow up the weapon and injure the shooter. We now examine improvised methods for attaching suppressors to the muzzle of the weapon. There is a great deal of literature available on improvised suppressors. A popular method in these books is the tape buildup method because of its simplicity and ease in attaching the suppressor to the muzzle. We experimented with the tape buildup method, but found it only acceptable for disposable suppressors, such as the one we see here, fabricated from a 2-liter pop bottle. A second method of attachment popular in the literature is what we call the split tube and ring clamp method. In this method, a metal tube slightly smaller than the diameter of the barrel is used. A channel is cut with a hacksaw or moto tool to allow the front sight to clear. The diagonal slashes you see in this barrel extension are to relieve the gases of muzzle blast. Additional cuts in the tube will allow it to slip over the barrel. A ring clamp will be used to secure it. Opposite the cuts, a grommet is slid down the tube. A PVC cap with a hole drilled to accommodate the tube is used. This provides a flush surface to epoxy the grommet to the PVC end cap. The barrel extension will be epoxied to the grommet as well, and a ring clamp will be used to attach the barrel extension to the barrel. The body of the suppressor will be made from a piece of PVC pipe which slips into the end cap. In the actual assembly, PVC cement will be used. The split tube and ring clamp attachment method can be adapted to many weapons using various size tubes. While quick and easy, we found two significant problems with the tape buildup and split tube ring clamp attachment methods. The first problem is that these methods do not ensure proper alignment. Each time the suppressor is removed and the ring clamp retightened, a different alignment is established. A misaligned suppressor is dangerous. The second problem is that these attachment methods are only secure enough for .22 rimfire weapons. Larger caliber weapons will likely blow off suppressors attached with either of these methods. What is needed is a more secure clamping system and a means to ensure proper alignment each time the suppressor is removed. An ordinary bicycle seat post clamp proved far superior to the ring clamp in holding power. The alignment problem was solved by using standard plumbing fixtures as the barrel extension, which were internally threaded. Let's take a look at the other parts of this assembly. First, the part we just saw slide into the bicycle clamp. This is the barrel extension, which will be cut to slip over the barrel. As purchased in a plumbing supply shop, it is an internally threaded part. The standard plumbing part you see here is threaded externally on both ends. This part will connect the barrel extension with the nut, which is internally threaded.